Here are the factors that should be defined for designing the assembly of the road before we start designing the layout of the road. Traffic, climate, and soil characteristics are required for designing the road. Since after we are getting this data, we can put them here in an Excel sheet tool for estimating the depths required for the designing of a road assembly based on ASTO standard. If you double click on it, you can access it and use it for estimating the depths of the road. Before we do anything, we need to create the surface on which we will work, whether our project is a road or a building or anything else. To create the surface, we need topographical data, which can be either points or contours. Let's use an existing project, an access road in Hull. The access road was designed to connect the project with the main road. The surveyor determined the contours of the field. On the left side of the screen, there is a sidebar called Tool Space. Right-click on Surface and then Create Surface. This surface is commonly named Existing Ground. Now that we have created the existing ground surface, we have to define it. We choose Definitions and the list of options appear. In our case, we right-click on Contours and we add the contours from the topographical data. As you can see, a 3D surface has been created. Then we create an assembly based on the design results using either British or other standards. We have to provide to Civil 3D the depth of the pavement, the base, the sub-base, and other relative data. For example, in this specific case, and based on the drainage design, which is not presented in detail in this presentation, we have to protect the road from the water with a ditch on its left. The next step is the creation of the road layout. The width of the road is 5 meters and the road alignment will be in the middle of the road. To create the alignment, we choose Alignment, create alignment from object, and then we choose the object we want to use for the creation of the alignment. Then we have to define the direction of the alignment. At this point, we can define the design criteria we designed the road, such as the standard we used or the design speed. The profile of the alignment shows the existing ground. To define the level of the new road, we choose Profile, Profile Creation Tool, and we get this menu. How we will design the profile of the new road is affected by a list of factors such as the maximum permissible slope or the drainage design. For example, maybe due to equipment restriction or health and safety reasons, we have to reduce the slope of the road. Or we may have to rise the level of the road in a specific distance above the existing ground to protect it from water. Let's say 20 centimeters. This blue line shows us the new road. Then we create the corridor for this specific profile. Let's name it access road, basic line 3. If we don't remember the name of the profile, we can click on it. Then we choose the ditch we built before based on pretty standards and the target surface, which is the existing route. Then we set all the targets to be on the existing route. Perfect. Apply. Rebuild the corridor. Okay. And now we have the corridor. As we can see, this green line is the ditch and the red line are the gradings of the road. So the next step is to create a surface from this corridor. We go to corridor properties, surfaces. We create a surface at the crown of the road. It's called top. And then we create another surface at the bottom of the road. It's called datum. Apply, rebuild the corridor. Okay. Now that we have the two surfaces, we can estimate the material required for cut and fill and for building the road by comparing them through analysis. Volume dashboards, we create another surface which compares existing ground with, let's say, the crown of the road, which will give us the cut and fill for the road. Okay. Here is the material we need for filling. Here is the material we need for cutting. With green color is the material for filling, red color the material for cutting. We can even show it on on our design. Surface properties. Let's create a copy. Definition analysis. We need two. We need green, red for cut, green for fill. Okay, 0, 0, apply. Okay, and we can show where we have to fill and where we have to cut material for creating this road. We can even show the material quantities we need. At surface, let's plant. We have to choose the surface we created. Let's make the table elevation here. And as we can see, it only provides us the area, not the quantities. We go to edit the table style. We create the volume. We add the volume. Volume. Okay. The 3D volume. No. So here are the units. We add it. Okay. Apply. Okay. And here are the material quantities needed for applying the process-based method. In a similar way, we can estimate the material quantities for the ditches, the earthworks, the structures, the drainage system, and any civil work